Good morning, and welcome to the second day of Google I/O. Thank you all who made it here bright and early, and a big warm hello to folks on the live stream. This session is about Android Things, the version of Android that was specifically designed for IoT products and embedded devices. My name is Vince, and I lead product management for Android Things. Yesterday, you've heard about the incredible momentum on Android. Over the years, we've extended Android into many different types of devices beyond phones and tablets, wearables, TVs, auto, and last year, we announced a new version of Android called Android Things, specifically designed for embedded devices and IoT products. I know many of you have been tracking our regular developer previews and are already building great things. I love reading about the projects. It's so awesome. For some of you, this is entirely new. You're just getting started and want to know what Android Things can do for you. So let me just get started with some of the obvious questions. What is Android Things for? What problems does it solve? People have been making connected devices for many years. What's different now is the profound revolution in machine learning. Powerful models and tools are available to all developers, and there's ever-increasing demand for smarter devices. Traditionally, your only option when building smarter devices was to delegate some of the serious processing to the cloud. Now, it's possible to run much of it on device, which is useful if you need low latency or if you're handling sensitive content, and so on. And this growing area is exactly where Android Things is targeted. It is for devices that need powerful, on-device intelligence. When we look around the devices that populate our homes and businesses, IoT is, of course, very broad and diverse. So in a sense, the product categories are all familiar. We all know these. It's just the user expectations that have gone up, way up. Let me just pick on two use cases. At home, we increasingly expect to be able to talk to our devices and they'll know who we are. Another one is smart building devices, such as cameras, that can now detect how many people are in a room and do something useful with that. For example, talk to the HVAC system. We know users want these kinds of devices, and we know we could build them, but of course, building these devices is actually very hard, especially maintaining them over time. It's actually very expensive to do this. We know this at Google because we've been shipping these kinds of products. Well, what's so hard? Well, first off, we're talking about an entire device, so a whole physical product. So we're responsible for the entire software stack from the bottom all the way up to the product experience. Now, of course, the product experience is where you'd ideally be wanting to spend most of your time, because that's where users are interacting with. Below the product experience, IoT devices are currently built using many different flavors of roll your own Linux or Android. Every device is different. So it's hard to expect consistent and reliable APIs. When you go from project to project, you want to reuse what you've built. You want to get support from a large community. At the same time, we're talking about richer experiences with these devices. So obviously, you need to get your app working. Chances are you need to get third-party apps and services working. Each time, you need to figure out basic building blocks, like a reliable setup flow from a smartphone, for instance. You could do it all yourself, but it just feels like extra time and effort. Second, you need to get down to the hardware. Building prototypes with microprocessor SoCs have certainly gotten easier over time. People use all sorts of prototyping tools to get that done. But those don't get you through to production, let alone commercial launch. We're talking about PCB design and layout involving high-speed, highly integrated components, SoC vendor relationships for general support and bring-up, component supply chain, access to parts in low volume, and so on. These are all very different skill sets you need to hire for your team. Again, prototyping solutions get you off the ground, but that's it. Finally, while it's amazing how much these devices can do on our behalf these days, the flip side, of course, is that they have the keys to our homes, our businesses, our back-end systems. Clearly, there's more and more to gain from attacking IoT devices. Perhaps less obvious is why it's hard to provide the security. Well, it turns out it's incredibly expensive to harden products out of the gate and to keep them updated over time. It involves a lot of back-end infrastructure to do this. We know this at Google because we've been doing this for many products. Meanwhile, there's immense cost pressure from end consumers, of course, and it's hard to amortize costs without large volume. So, those are the issues that our engineering teams and our business teams focused on when we built Android Things. The thinking was we could take care of all the challenges that make development expensive. We provide Android Things free of charge. You have less to worry about. Our goal is to reduce the barrier to building powerful, intelligent edge devices and make it more accessible to everyone. Now let's take a look deeper. About building on reliable and consistent APIs, Android Things is Android. As you'd expect, you can rely on the same Android APIs and Google services as when you build for phones. Familiar tools such as Android Studio and the Android SDK are available. You can build on Google Play services, Google Cloud Platform, Firebase, including the most recently announced ML Kit that you heard about yesterday, and more. Of course, you're building hardware. So it's also about component providers, SoC vendors, and so on. As a device maker, usually you'd be spending a lot of your time interacting directly to get to a working image. With Android Things, we've already done the hard work for you. That means you have access to hardware reference designs. It means the build support package comes from Google, and you get a working image right away. You can scale to production because we've signed agreements with the SoC vendors to guarantee support over the long term. Literally, our goal is, if you know how to build an Android app, you can now prototype IoT products and take them all the way to production. You don't have to be a hardware engineer or firmware engineer to do this. Finally, on security, our strategy is to have security features built into the platform. OS hardening is on by default, and you don't have to spend time figuring it out yourself. What about fixes over time? Regular security patches come regularly from Google. Google provides all the backend infrastructure for you to be in control, and you can decide when those go out. Now, let's go a bit deeper. How do all the pieces that I just talked about fit together? Developers often ask me, how is Android Things different from Android? How is it different from AOSP? I found that the best way to describe Android Things is that it's a fully managed solution beyond the AOSP model. At the lowest level, we define turnkey hardware in partnership with the silicon providers. This is in the form of a system-on-module architecture. I'll talk more about that in a bit. But the way the model works, though, is that we work closely with the SoCs to land code in the Google tree. Google is the one hosting the BSPs. In fact, we have the system on modules in our test labs hooked up for continuous integration. Moving up to Android in the framework layers, Android Things is Android. What we've done is we took Android and we shrunk it down to around 50% of the footprint of AOSP, meaning it can run with lower compute and storage requirements. Security features are built in, meaning they're done for you and they're on by default. Up at the top is the app layer. We formalized the boundary so all of the product-specific code lives there. We make sure the Google services you might want to work with work well out of the box. So your apps can rely on Google Play services, Firebase, Cloud Platform, Assistant, and more. Finally, what's pictured on the left side is the management console. It's shown cutting across everything from bottom to top because it's where you control what exactly goes into your devices. It's where you get access to the BSP that Google and the SoC vendors are supporting. It's where you create full product builds with all of your apps and services included. It's where you manage releases and update channels over time. As you can see, that's why I've described Android Things as a fully managed solution. It gives you a portfolio of reference hardware to choose from. It gives you Android with security and key services working on top. It gives you a console to configure what exactly goes into your devices. It's all of the ingredients necessary to prototype and scale to production. On behalf of the entire Android Things team, I'm super excited to share that we are now generally available. Version 1.0 is the first long-term supported release. It came out just 2 days ago on Monday, fresh off the press. Many of you have helped us along the way. We've seen more than 100,000 downloads of our Android Things SDK. We've received feedback from more than 10,000 developers. This was all critical to get us to this point. Thank you so much. Now, what does version 1.0 mean for you? Most importantly, it means Android Things is a stable base for you to build commercial products. In fact, we've worked with a few partners to put Android Things through its paces and vet whether we could power real shipping products. Let me show you a few. What you see here is our first shipping product, and it really put our program to the test. This is a smart speaker by LG, and it landed on shelves last month. So the story is, LG wanted to build a smart speaker with high-end audio and go to market quickly, and they felt we'd be a good fit. One of the first things was to determine a good hardware reference design. The system on module architecture that we talked about before is in all the shipping products. From your point of view, this is all done, so you can just pick it up. It will be an officially supported platform, and you're good to go. Well, LG was also concerned about ongoing security fixes and the infrastructure to send over-the-air updates. Bottom line is that these guys want to be working on amazing audio, not worrying about staffing up a team to do security and do OS bring up. This is a smart speaker, so there's non-trivial audio processing for audio casting and the Google Assistant. We make sure these work well, and they're part of the full solution as well. There's more OEMs working on smart speakers, and they'll be coming out in retail soon. Soon after, partners chose us for a new product category called Smart Displays. The idea is a visual Google Assistant. There's deep integration with photos, maps, video calling, YouTube, and so on. What you see here are devices from Lenovo, JBL, and LG. All these guys wanted to move quickly, and they felt that we could help them do that. At the time, we were already working with SoC vendors on expanding our portfolio, and we locked in on a common system on module for all these products. In other words, if you look under the hood, all of them are using the same system on module, which is quite cool. Again, when you work on your project, you can just skip all of that upfront SoC work and just pick up the supported design. The OEMs were also concerned about ongoing updates, especially because this is a new product category. They're expecting frequent updates, and during development, they wanted to partition folks into different groups and A/B test the user experience. This is where our console was put to the test to manage all the builds, release channels, and frequent updates. Now, of course, IoT is broad and diverse. What's the most exciting for me is seeing what everyone has been building based on our developer previews. Here are two examples. The product on the right is made by a company called Byteflies, a wearable health startup based in Belgium. The hand is holding a sensor that measures vital signs, and the docking station sends data back to the cloud. Byteflies let us know that Android Things help turn their docking station into a secure hub. They don't have to worry about ongoing security fixes and how to update the device. The product on the left is made by a company called Morigo, based in Montreal. They built a network of large photo displays running Android Things, and they're connected to public photo booths in downtown Montreal, which sounds really fun. Morigo wanted a solution that could help them move quickly, and Android could help them do that. If you're building a new product powered by Android Things, we want to work with you too. We introduced a special limited program to partner with the Android Things team for technical guidance and support. If your company is interested in learning more, please let us know at the link. So now that I've shown you some real products, let's switch gears and go back to how all the pieces fit together, starting from the bottom. We talked about the hardware reference designs. We talked about the system on modules. You might be wondering, what do they actually look like? So on the right here is a system on module, SOM for short. This one is based on an NXP IMX7D. All the high-speed and complicated-to-design electronics are in the SOM. The key components such as the SoC, memory, flash, Wi-Fi, Bluetooth. The baseboard is what you see on the left. This one shown here is actually one of our development baseboards. But you can imagine designing product-specific baseboards with just the right set of connectors and plugging the SOM on top. The SOM is complicated and quite costly to design if you were to do it yourself, and we've done the hard work for you. It would also be very expensive at low volume, but the SOMs are what everyone will be using, and that helps drive up volume for everyone. The baseboards are much less expensive to produce, even at lower quantities. The electronics are much lower speed and less dense. What I've shown here is also referred to as a physical SOM because the SOM is on its own board. You could also imagine designing it in so it's all on one single board, and we call that a virtual SOM. This would allow you to save on cost at high volume or to better match XY dimensions for your product. Going back to the 3 smart displays I showed earlier, they all use different tactics. Some use physical SOMs, and some design it in virtually. For each SOM, Google hosts the board support package, BSP for short. In other words, you don't have to interact with the SoC vendors. There's a stable layer of separation with the BSP that makes your code portable. You could imagine starting development on one SOM, then swapping over to another at later stages of production if your design changes, without having to change your code. Now, part of making the SOM architecture viable is guaranteed support. Behind the scenes, we've been working really hard with the SoC vendors to work out the collaboration so you don't have to talk directly to them. We are announcing SOMs that are certified for production. The list includes hardware from MediaTek, NXP, and Qualcomm. More specifically, SOMs on this list have guaranteed long-term support and all security features built in, making it possible to bring prototypes and go all the way to production. Hardware and reference designs for these SOMs will be available in the coming months, so stay tuned. SOMs supported for development is already available now. They include hardware from Raspberry Pi and NXP. Development hardware have a large community of support and are readily available in retail even at unit quantities, usually for cheap, so that gets everyone started right away. The beauty of the Android Things model is that you can easily swap over to SOMs certified for production once you're ready. So, everyone has been wondering, for the list of SOMs that are certified for production, the ones on the left, how long is the support? How much does it cost? Each SOM certified for production is supported by Google for a minimum of 3 years from the time it was first made available. What this means is you will get regular security patches and stability fixes from Google for you to push to your devices. You can even set your devices to auto-update and not worry about it. In other words, you get to fully harness the power of the Android security team. Of course, you can push your own updates to your devices anytime you want for the entire product lifetime. Well, what about fees? There are no charges to using Android Things. There are no license fees for the OS or the management console. The API surface is stable, meaning the length of support is provided for each major version. This is why we refer to 1.0 as long-term support. We know moving to a new major version can be disruptive, and it may not make sense for many IoT products, so there's no need to do that. Let me show you in a bit more detail. Each line on this chart represents a major version of Android Things, and of course, 2.0, 3.0 are in the future. As I said, every major version will have long-term support, the minimum 3 years we talked about. These major versions do map to underlying Android desserts and will pick the right points to intersect over time. The important point is, when 2.0 comes out, 1.0 and 2.0 are supported in parallel. The security patches and stability fixes come regularly, and that's what each white dot in the lines represent. We'll also have minor feature updates on the latest major version. This is so we continue to address community feedback in a timely manner. So we won't wait for the next major version to push these out. In fact, in the coming months, 1.1 will come out with improvements for you. One last note on SOMs. Obviously, the work we do behind the scenes with the SoC vendors is never ending. It's an ongoing process. We'll continue to expand the SOM portfolio. You saw the vendors that already have something listed officially, and we're deeply engaged with others too, like Rockchip. The point is, once we put a SOM up as certified for production, it's a commitment. The ones you saw all support 1.0, and when we eventually add 2.0, we'll be explicit about which SOMs support it. Now, we've been talking about the next layer up already, since Google hosts the board support package for every SOM. But what does it actually look like? Let's go into that in a little bit more detail. What you see here is a simplified software stack for a traditional Android mobile device. Going from bottom to top, the kernel up to the HAL layers is primarily focused on enabling hardware support. The Android framework provides a rich set of APIs and services for apps. And the applications on top provide user-facing features, right? Now, in IoT devices, you can imagine many of the included components not making sense. Well, you know, embedded devices are usually single purpose, they may not have a screen, users are not installing apps, and so on. So, first, Android Things removed most of the user-facing applications and visual framework components that don't make sense. For example, there's no reason for a text messaging app. This removed unnecessary complexity and reduced the footprint of the distribution. If you build a device with a display, you have full control. There's no system UI to get in the way. Now, with or without a display, the UI toolkit portions of the framework remain available to your apps. Activities are still the primary component of an Android app. The framework delivers all input events to the foreground activity, which has focus. Next, we formalize the boundary between the system and the product-specific code necessary for the device. All the product-specific code is above the line in the app layer. Everything below the line is provided by Google and our SoC partners. This way, you don't have to figure out how to put together a working image. Google can sign the full image and guarantee automatic security updates over the support time frame. You might be wondering how this boundary can work in practice. Well, one crucial piece is the Android Things support library. I'll touch upon the API surface briefly. For example, you may be wondering how to control hardware. The Peripheral I/O API allows apps to interface directly with low-level peripherals using industry-standard protocols like I2C and GPIO. User space drivers allows apps to inject hardware events into the Android framework. You might be wondering how to call APIs that usually involve a dialog or a view to the user. These don't make sense when displays are optional. So we've added APIs to control settings, control device updates, and configure local area connectivity, including Bluetooth and low-pan. Now, I'd like to show you the complete picture. We've already talked about the portfolio of SOMs you can select from, and these come in at the bottom. There's actually two more building blocks. The first is device configuration, and the second is security. Let's start with device configuration. It's the other crucial piece, along with the Android Things support library, that helps maintain the formal boundary that we just talked about. You see, SOMs can support a wide variety of hardware, so in many cases, the OS needs to know which hardware is actually connected in order to properly configure those interfaces. For instance, which audio devices are connected where, and their formats. Pin muxing. We provide a configuration system so OEMs can define their connected hardware in the console, which will customize the image correspondingly at build time. Cool. Let's talk a little bit about security. Well, first off, the OS hardening that we do on Android is enabled for Android Things. So these are things like permissions, the application sandbox, mandatory access control with SE Linux, kernel syscall filtering, and so on. Images are signed. You don't need to run any signing infrastructure yourself. Google provides the infrastructure to build the full image for you. Disk partitions are signed for security. Verified boot, which is fully implemented for SOMs certified for production, make sure you're running a valid image at all times. Now, there's lots of interesting scenarios that are handled for you, and I always get a kick out of thinking about them. For example, what about running an older image with a vulnerability that has since been fixed? Rollback protection makes sure this doesn't happen. Another one is per product keys. So images only run where intended. You can ensure only your product images run on your devices. Finally, you don't need to run any update infrastructure. Google takes care of building and serving all updates, the same infrastructure we use for our own products. All right, now we're moving on to the app layer, where all of the product-specific code lives. What does building an app on Android things look like? To get started, we want access to the Android Things support library we just talked about. It is built into the supported devices as a shared library. We're showing code snippets from 2 files here. At the top is a snippet of the build Gradle file. You declare the SDK dependency there, and it'll get pulled in. The bottom part is a snippet of the Android manifest file. You notice we use the uses library tag so our app can access the device's shared library. Below that is applying the home category to one of your activities. What this does is that the system will launch this activity automatically on boot, and will launch it if the app terminates. This is, of course, exactly the behavior you'd expect for embedded devices. Now that we have this set up, let's do something useful. The example here is very simple. It detects a button press, but it's a good demonstration of how to interface directly with peripherals using the Peripheral I/O API. The code snippet at the top is the Android manifest file. This is where we declare the required permissions to use Peripheral I/O. The code snippet below is the activity. There we use the Peripheral I/O API to open a connection to a GPIO pin, which is where the button is connected. We configure the GPIO pin as an input and attach a callback. And that's pretty much it. Good to go. A similar workflow is used for all of the Peripheral I/O interfaces. So you can imagine adding a few lines, and you can light up an LED. Of course, it's not just about simple stuff. There's a wide variety of peripherals out there. Your app can interact with all kinds of sensors, actuators, and so on this way. We've expanded our community hub this week as part of the 1.0 announcement. The site is androidthings.withgoogle.com. It brings together all of the information in one place: samples, documents, forum. Also, as you'd probably guess, much of the code we showed before about driving hardware peripherals isn't exactly product-specific. You can get up and running quickly with pre-built drivers from our peripheral driver library. These drivers abstract the low-level communication details associated with many common hardware peripherals. You can browse the driver library at the Community Hub, and we're also now accepting community contributions as well. So let's all make this better together. Be sure to check it out. Well, where do you go from here? Well, you have full access to the Android SDK and NDK when building apps. You can use Android Studio, develop your apps in Kotlin. You can leverage standard developer tools and third-party libraries. Many projects find Google Play Services, Firebase, Google Cloud Platform, etc., very useful. In fact, you can create an end-to-end demo very quickly. For instance, if you're collecting sensor data, you can use Cloud IoT Core to help you ingest data and do something with it in the cloud. If you're taking photos, the Cloud Vision API, for example, can help you with object detection. Of course, there's a lot more. We'll have many samples in the community site for you to check out. Let's say a bit more about Google Play Services, because we've created an optimized, lighter weight version of that for Android things. It's optional, so it doesn't take up space if you don't need it. Many developers do find it very useful, though. You can literally tick a checkbox and add it to your build from the console. You can find the Firebase APIs in there, which we use in many of our samples. For example, the real-time database is very useful when you sync device data. You can also use the new ML Kit to integrate Google's machine learning technology into your app. There's, of course, a lot more in-play services, fused location APIs, nearby for setup, maps, and more. The final piece to Android Things is a console for managing what's running on your devices. It's shown vertically, cutting across everything from bottom to top, because that's where you manage all the builds and releases for your entire device fleet at every stage of the product development process. Let me explain. Here's a very simplified view of the product development flow. Every product goes through the prototyping phase where you just want to get something working, then a series of hardware validation manufacturing stages, and finally, commercial launch. At the beginning, you may pick up one of the development SOMs because that's the easiest thing to do, and then later swap to one of the SOMs certified for production. After you get the hardware, you might be wondering, well, how do I assemble an image and push it to the device? In the prototyping phase, you probably just want quick access to a generic image and to get you going. You might only care about one device. So you go to the console and tell it which SOM you've chosen, and that's pretty much it. You can then flash the supported image and siloed apps to your device. As your product evolves, you'll come back to the console to customize a lot more. For instance, you may want to change the partition sizes. You may want to include Google Play services because your apps need it. You may want to modify the device configurations at build time based on the peripherals that you're connecting. You may start caring about a lot more devices. For the smart displays and the smart speaker devices that we showed earlier, the OEMs use the console to split devices into groups. So developers, QA, early beta testers, they're all in different groups. They all have different builds and on different update channels. All of this is configured from the console. When you go to production, you obviously need to assemble the, previous slide. When you go to production, you obviously need to assemble the entire factory image that includes your apps and services. You want to update your app over the lifetime of the device. It's important to have control over rollout. For example, rollback if something goes wrong. Gradual percentage rollout so that you can go slow and check that things are going well. Access to metrics so you can see that things are going in the right direction. All of this is why the console exists. The underlying backend infrastructure is the same as what Google uses for our own products. So, just finished explaining how Android Things is a fully managed solution. We have a lot more to show you at I/O. Come and see us at our Sandbox Dome. It's the giant bright orange one. It's hard to miss. The entire dome is filled with Android Things demos. You can see how real commercial products evolve from prototype to production, the smart displays. You can see them all there. We talked about devices getting increasingly smarter. We have demos showing machine learning, ingesting real-time video, so it can recognize emotions, faces, handwriting, and so on. By the way, you notice Android Things powering devices outside of the dome as well. They're powering the survey boxes all around I/O for instant feedback. There's a 5-foot-tall robot roaming around somewhere. It's hard to miss that one. Android Things in there. If you like to code, come to our code labs and get hands-on. We have one showing how to work with TensorFlow, Cloud IoT, how we made the survey box, and more. There's 8 more sessions coming up today and tomorrow that go deeper into specific topics. For example, the session at 11:30 today talks about how we built the smart display product, the journey all the way from prototype to production. The last session we have tomorrow talks about the console in detail and how to manage your devices at different stages of the development process. Finally, let's all have some fun at I/O. Join our scavenger hunt at the link g.co/IO search. You might have seen this already. There's very cool machine learning enhanced flowers that you'll notice. Solve the puzzles and you'll get a free hardware developer kit. With that, let's all go build some hardware. If you know how to build an Android app, you now have a new superpower. You can prototype IoT products and bring them all the way to production with Android Things. You don't have to be a hardware engineer or firmware engineer to do this. Pick up a kit from the scavenger hunt, then head on to androidthings.withgoogle.com to get started. This concludes our talk. My name is Vince. Thank you, and good luck.